Hello, everyone. We're going to be walking through our project for CNT 4713. Um, so basically, this is our server file. It handles multiple clients at the same time using TCP sockets. At the top, we have three standard libraries here. Um, we have socket, obviously, for networking. We have system sys for command line arguments, and just starting so we can handle multiple clients. Over here we have a global variable dictionary clients. So obviously just to keep track of all the usernames that get logged in. Next we have a couple helper functions. We have send response, which is just the core one, since every response the server sends just goes through here. It takes in socket, uh, status code, and optional data. Default is set to none. So it basically formats it into a single string and just sends it. Then we have the send to everyone. It loops over every connected. Um, and then it just calls the send response on each one, right? Over here. So we also wrap it in try except, just in case one broken exception just doesn't crash the whole broadcast. So yeah. And then we have send to others, which is practically the same thing, but it just skips one specific user. So it's just useful when someone wants to broadcast a message and we don't want it to basically um, just echo it back to itself, right, to themselves. We just want the other user to see it. Um, then we have the handle client function. So it runs in its own thread for each client, and it just manages that client from connection to disconnect. Um, it starts by accepting the data socket connection, um, and every client uses two sockets, right? One for sending commands and one for receiving data back. Um, and then we enter a loop. We read from the control socket, um, we decode, strip it, and just try to parse out the command words, right? So, for example, the ones in the project were login, or who, broadcast, and things like that. Um, so for who, um, pretty simple. You just join all the current usernames into a comma separated string, and then you send it back, right, with the send response function up top. Obviously the data was set to none, but we're passing it in with all the user lists. And then we have the broadcast, right? So we extract everything after the word broadcast, right? Since the command is broadcast. Um, and then we just call send to everyone right down here. So all connected clients can just receive whatever the text may be. Um, so up next we have the private, right? So private is split into three parts. It's of course the command private, it's the username, and it's the message. So yeah, and then so if the recipient isn't logged in, we actually send the 500 error code. Um, Otherwise, you send whatever the response is, the messages to that specific user. So quit, pretty straightforward, right? So just print who's quitting, send the 200 back, and then break out of the loop, right? And then the finally block, it always runs, right? So we have the try, we have accept, and then we have the finally. Um, it just always runs whether we broke out or we just hit an error, right? Um, and then we also remove the client from the dictionary. And it also just tells everyone that they left. Um, so the main function here, of course, this is the entry point. It reads the control port from the command line. It creates the main server socket, right? And then it just starts listening. And then, of course, it prints the waiting connections according to the PDF. So yeah, and then we also loop forever, right? Unless we hit Control C, which I'll show at the bottom. It just loops forever, waiting for new clients. And then when one connects, their first command must be connect. If not, it'll just give an error for that. And then for each connection, of course, we have a new socket we bind it to 0, so that way we let the OS pick any port that is open to us, and we just spin a new thread. And of course, Control C just X's out of it, and then we have a finally here that just closes out the socket.
Hello, my name is Richard Marinon. This is my recording for my project 1 for the class CNT 4713. I worked on the client file. I'm not going to start here because my teammate did this part, so I'll let him talk about that. But I started down here. What I did was write this code primarily for the sending client. Here we initialize these variables. Everything down here is in a while statement, so it keeps running. Here, initialize user parts in command. Here, we start with the client side commands. So here's the connect command. User parts. It reads the input as a list and accepts it like that, and it stores it. It tries. If it's not integer, it gives an error. Client socket, this connects to this, initializes the connection socket to the server, and this gets the server responses and checks. This is for the connect command. If the server message is 200, it responds with a confirmation. The status code received, starting data connection port. On which port? It tells the port that the server gives. It creates the data connection socket, and it keeps going. Now we keep going here. Else if the command is quit, this test if the client already connected. If it didn't connect, it prints out you must connect first, then you continue. Client socket send all sends the user input to the server, receives the server input. Client socket all sends the user input to the server, and this receives it. The server response is 200. We say status code received with the message from the server, and we close it out and break exit the loop. Else if command equals login, same thing as the code above. Test to see if the client already connected. If they did, continue. If the length of the user parts is not 2, you gotta make sure that the client is inputting login and username, continues, sends information to the server, receives the response, gets the response, prints it out. For this part here, my partner did it to tie into their listening function for the to use threading to listen to every client input so that it could show on both clients. So here, else if command who, same thing, make sure they're connected, and send the information to the server. These lines of code are commented out because I initially only made it so that one client would display the correct output, but then when we tested it with two client files open side by side, this would just show up on one, but it wouldn't show up on the other. Broadcast would not broadcast to the other client file, and that's where this function comes into place, and that my teammate Benz will take over and explain that.
All right, hello. My name is Benz, and for this section, um, I implemented the threading aspect because originally there wasn't any, and being able to run this without the threading was causing problems because we needed to run two clients at the same time. And so what we first did was added the listening for messages and make it while true so that it constantly is in a listening loop so that it like the clients just remain active and ready for any messages to come by. This here, the data socket, the server response basically just means that it blocks a thread and then waits for the data to arrive from the server and through the data socket. Um, this the server message, server response dot split lines line basically just makes it so that the wording is formatted correctly for any inputs we put into the terminal, just like as it was just like the examples in the project wanted it, so that this is what we did. The length server message equals 0 here is just in case that if nothing is inputted, then we just move on and continue as if rather than generating error, we just move on instead of and returns to the listening for the next upcoming message and all that. Um, This function generate helps so that when there's an error that does happen, it'll generate a 500 status code received. So it handles any error processes. This one handles any broadcasting. So it takes, let's say, it takes these two things into a list and put, gives them variables like sender name and message text. And for any message that ends with all, we're gonna be deleting them because according to what we saw in the examples, all was basically deleted from the phrase hello all, and we'll see that later on. And so we would print the message, we would say 200 status code received, and then we should be able to see that broadcast message from whoever sent it, like Alice or Bob, is is then going to be shown what that message is from the receiving client. The same goes for here on the private command, in which we have the sender name variable and sender and the message text we put into lists. So when that command executes, we will have a 200 status code received, and then the name Alice or Bob or whoever would be printed out, and then what that message text is privately to that person. The next is the who command. So in this section, the process is generated by the who command. It lets us see which clients are available on the server. So we put the variable connected users into it equates to the list of server message 2. And so when we print out the who command, it'll be 200 status code received, who are the users connected, and then shows you the connected users, it being Alice, Bob, Mallory, whoever. Nothing else happens, then it'll just execute this as a rather than ignoring the response, it'll just successfully do the request. It's like a fallback type of thing. And then that's where it'll end. So let's try to run this code in its entirety by opening up 3 terminals. Not like that. First with the server. Then with one of the clients. We connect with this IP and port, and then we log in as Alice for this client. The same goes for this terminal. We connect with the same port and IP, and then we log in as Bob. So let's test out one of the commands, which is going to be who. And for this case, it'll show you that Alice and Bob are connected, which is true in this case. Next, the command is broadcast, which should just broadcast a message to all the other clients. Let's say hello all. That's what it says here. And it cuts out the all just as shown in the example. And then we do private Bob, let's talk. So this should specifically be sent to let's talk. And it shows us the 200 status code for each and every one just to show that that it has been executed. And then we quit. And then it will show us that a quit has been requested by Alice on the server side here. For Bob, we could do the same. We quit. And it'll also show us that quit requested by Bob.
This is the Wireshark demonstration or TCP stream that I'm going to be following. I started off by already fully running the two clients, just like the expected output and the server, everything. I ran it all the way through and quit the system or the file. And here I ran a Wireshark capture. Now I'm going to go here and filter out through the port. I'm going to select the port that was given to, let's say, Alice. 64 58 7. And now here, these are the messages from Alice to the server. So let's start from the beginning. Here, Alice types in connect 127, connects to the server, status code 200 is given, the IP is given. And to continue, every time that Alice types something in and the status code returns as 200, it sends it to the server. The server confirms it. Alice and Bob 200, this is for the who command. This is, of course, the broadcast Alice. Hello, Bob, how are you today? 200, 200, meaning that it's confirmed in that order. Now, continuing. Here, connect. This is Bob's connection. He connected successfully to this IP, 64596, login Bob. Now here, broadcast Alice. Hello, Bob, how are you? This is Bob receiving over here that message from Alice. Private Alice, hey Bob, what's up? This is a confirmation from the server that he got it. And yeah, that's pretty much it. That's a demonstration of Wireshark communication from the client with the servers.